Good morning, Year 6. It is Thursday the 18th of June, and today we're looking at decimals as fractions. So let's have a look at our anchor question. So match the decimals to their fraction equivalents. So remembering equivalents just means the same as. Okay, so looking at this, we look at our first one as 0.1. Okay, and then we're going to move towards other ones that are commonly known. So 0.5 to a half. We know that one is correct. And we also know that, looking at the other ones, 4/10, 0.4. We know that is correct. Then looking at the other ones, a little bit trickier, but not overly. So thinking about, well, we know all decimals are over 10. So if we're to convert these two fractions to over 10, we've got 4/5, so that would be 8/10. So that would be that one. And then just checking, even though it's the last answer, 3/5 is 6/10, so we can see we have got 0.6. Looking at our next question, write as a decimal and a fraction. So here, so as a decimal, we'll start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 parts, and we've got 5, 6, 7 shaded, so it's 0.7. Now knowing 0.7 as a fraction, we've got 8 parts shaded, so it's 0.8. And then we know 0.8 as a fraction is 8/10. Okay, so that's how many shaded and our total parts are 10. But then simplified, well, let's have a think about that. So both have a highest common factor of 2. So if we do 2, 4, 6, 8, 4/5. So it is 4/5. Let's have a look at today's video, and that will help you with today's learning.
Hello there and welcome back. Today we're going to think about decimals as fractions. We're going to start off with this decimal right here. So we've probably come across this lots of times, and we might call it 0.1, but we say that the value of the digit 1 is 1/10. And 1/10 as a fraction, we would write 1/10 or 1/10. Or 1 out of 10 parts, or we'd say it 0.1. So let's think about that 1/10. That means 1 split into 10 equal parts. That's represented by a bar model. So if 1 is split into 10 equal parts, then the value of each of those parts will be 0.1, or 1/10. So 1/10 is equivalent to 0.1. So if 1/10 is equal to 0.1, what would 6/10 be, and what would 0.3 be equivalent to in terms of tenths? So pause the video. What would those two values be? Okay, 6/10 would be equivalent to 0.6, and 0.3 is equivalent to 3/10. We've got 100 square now, 100 equal parts. And of those 100 equal parts, 17 are shaded in. So 17 hundredths is represented on the 100 square. And we'd write that as the fraction 17/100. Now, as a decimal, if we know that 10 hundredths is equivalent to 0.1, and we know this because, well, if we counted up 1 hundredth was 0.01, 0.2, 0.2, 0.03, etc., etc., 10 of them would be 0.10 or 0.1. So we can represent 17/100 as 0.17. 2 feet till I got it now. Look at the 100 square and decide what would that be as a decimal and as a fraction. Pause the video, have a think. Let's have a look at the first one. Well, 39 out of 100 are shaded, so that would mean the decimal would be 0.34, because it's made out of 3/10 and 9 ones. And the last one would have been 60/100, which you could write as 0.60. Although that last 0 we don't need to write, because 0.6 is the same as 0.60. But let's have a look at that. We can write 60/100. Why is that the same as saying 6/10? Well, if I could visualize splitting that 100 square into 10 equal parts, I can see that 6 of them are shaded. So 6 out of the 10 are shaded in. So that would be 6/10. Let's move on from tenths now. We've represented our tenths in a bar model, but let's compare that to a bar model split into 5 equal parts. Using the bar models, can you work out what decimal 1/5 would be equivalent to? Well, I can see that 1/5 is equivalent to 2/10. They're same in size. So 2/10 I would write as 0.2. So 1/5 is equivalent to 0.2. Let's take that example. 4 fractions here. Can you convert them to decimals? I'll find their equivalent decimal. Pause the video. Have a go for yourself first. Let's have a look at 2/5. Let's shade 2/5. We know each fifth was 0.2, so 2/5 will be equivalent to 0.4. What about 4/5? Well, 4/5 would be 0.8. Another way we could have thought about this was that I noticed that 2/5, if I doubled it, it would become 4/5. So double 0.4 would be 0.8. What about 3/5? Well, 3/5 would be 0.6. 6/5, well, that's larger than the bar model I've got here. But again, I can notice the same pattern. The numerators have doubled while the denominators have stayed the same. So the decimal equivalent will be twice the size. So 0.6 times by 2 would be 1.2. What would a 20th be, though? Pause the video. Have a think for yourself first. Let's have a look. Maybe it would help if I compared them next to each other. Well, I can see that a 20th is half the size of a 10th. So what would be half of 0.1? Ah, yes, 2 lots of 0.05 would be equivalent to 1/10. Or 5/100ths plus 5/100ths is equal to 10/100ths, which is 1/10. So 1/20th is equivalent to 0.05. Knowing that 1/20th is equivalent to 0.05, can you figure out what these would be as either fractions or as decimals? Pause the video, have a go. Let's have a look at the first one. Well, I could do 0.05 times by 5, which would be 0.25. You may have simplified the fraction to become a quarter, and a quarter is equivalent to 0.25. What about the next one? Well, I notice that 0.5 is double 0.25, so I need to double the numerator, which would be 10. What about the last one? 0.95. Well, I can see that that's just a little bit smaller than 1 whole. In fact, it's 0.05 smaller than a whole. So if I take away 1/20th from 20/20ths, it gives me 19/20ths. It's 1/20th less than being 1. What about the next one? Well, 12/20ths would be equivalent to 0.6. Well, I can see the relationship between 12/20ths and 13/20ths. It's 1/20th more. So I just add 1/20th, which is 0.05, onto it. So 0.65. And the last one, I can see it's nearly a whole. It's only a 20th more. So I would do 1 plus 0.05, which is 1.05.
Okay, so have a go at the work today. Also, don't forget you're learning by questions. The code has been emailed to you and is also on the website.